Yes, hello. How are you, everyone there joining us? You're with Joseph Willrich Lutalo, and yeah, we'll go through a quick exploration on the wood part of our Blackboard adventure today. So, as it happens, it is 2025, and I've winded up my master's. Now, looking forward to starting PhD work. So here on the blackboard, I sketch out an idea of what could be explored as part of doctorate research concerning the voice-operated support assistant. So the old VOSA is to be tentatively combined with the project and work we've been doing with the transforming executable alphabet, the T language, to create what we call the extended VOSA. So what is likely to be part of that project after we combine these two is that we envision coming up with a more intelligent interface that is from the human-computer interaction angle. Also, the knowledge models are going to be lightweight, however, they are going to be more robust and more capable. Like, for example, we are looking at the possibility of fitting an entire complex knowledge model within a QR code. Currently, the QR codes are only used for information retrieval, the model itself being hosted on a server, maybe in the cloud. But we are looking at ways of compressing these models. That's where T also will come in, because it's powerful with text processing. And also dynamic interactions, like, for example, adding context awareness, so that when you're interacting with this personal assistant, it is able to take into context things like time, your location, past interactions and things of that sort. Also, the responses are going to be dynamic in a way, so we're talking about variable responses, and here we're going to see how that may come in. So first of all, these knowledge models that VOSA uses are based on QAKBs, question answer knowledge bases, and we are saying that these knowledge bases are going to be sort of evolved into what we are calling meta knowledge models. So meta knowledge models is going to be part ontology, which is the current implementation of where you have questions and what answers they may map to, or topics and what descriptions or content they map to. But also we are going to combine in some content generator programs. So embedding T programs in the knowledge model is going to create what we are calling meta knowledge models. Then this is going to enable us, of course, to be able from these meta models to have dynamic content generation. So where you could have written a QAKB or a simple knowledge model that describes, let's say, the items available at a restaurant on the menu, you could now have a dynamic knowledge model that can describe a customer, let's say, what to eat or what to order for or drink based on the weather, based on the season, based on the past preferences of the customer, but yet the basic model is still the same. Also, for example, we are looking at some creative things like a knowledge. Currently, we have some knowledge models that are meant to help VOSA assist people in maybe saying prayers, like what we are calling companion prayer companion robots. So instead of saying the same prayer every day, like the same Our Father, normally when you're praying with a family or with friends, people come up with different phrasings or different ways to say prayer that might still appeal to the same theme but expressed differently. So we could have a robot you can sit down and pray with, but when it says something new every time you sit down to pray, with the dynamic content generation. Also, that is going to still leverage the scan to know, information access and retrieval. So that is because we are still using QR codes to encode the knowledge models, this time not only for retrieval but also for embedding the knowledge model in the QR code. So that is part of that, and we expect that this is going to be a very exciting research, because VOSA's knowledge models are very interesting. For example, if you're a tourist and you have just arrived in a new location, you don't need to download a lot of information to ask a robot questions about where to go or where to find what services or information. You can just scan a QR code and the robot will know how to answer your questions concerning that very particular topic. Let's say you've arrived at a national park and there's an aquarium and you want to know what species of fish are available, etc. So you don't need to Google, you don't need to download a huge language model or knowledge model from online. You can just scan a QR code and immediately you can start to ask questions, what is the species of the red fish, how many species are here, etc. And it can be answering to you. And mostly this knowledge model can be offline. That's why we're talking about embedding it in the QR code and also having dynamic content generation programs as part of the knowledge model, instead of pulling most of the content from online. So the only interactions that might be still leveraging online resources are the text-to-speech and the speech-to-text. But later on, after we worked on NLP mechanisms to make the entire thing offline, you could find that this may be the best personal assistant engine or architecture that can purely work offline. So meaning you don't need internet and it can work in remote places where there is no connectivity, but as long as these knowledge models have been already encoded and expressed or placed inside these QR codes, which can be scanned just to the camera, and then the augmentation of the intelligence of the robot happens, and then you can start interacting with it, asking questions, and then it's back to you. So yeah, this is kind of like a high level glimpse of what could be possible when we are doing this this research.